Okay, this week's lesson is this video lesson, and so if you're here, you found it. That's very good. We're going to be continuing with the assemblies that we started last time, but rather than looking at an assembly of parts that are static, non-moving, we're going to look at an assembly of parts that have to move. And so you will find on the online classroom site a file that you can download called mechanismparts.zip, and I have already downloaded and unzipped those parts, and so I'm going to drag my Windows Explorer window into view a little bit that shows those parts. I'll drag it a little further in. Matter of fact, I'll drag it all the way in. And what I'm going to do is use these parts to create this mechanism. First thing I need to do, though, is create a new assembly. And so I'm going to do File, New, and if I go into Advanced on my drive, I don't have a millimeter assembly. I guess I've never saved one, so I'm just going to then do a standard assembly. But I will go ahead and make it metric fairly quickly. Let's see, let's unpin that menu that I did accidentally and collapse that. Or maybe I want to make that menu go away. Let's see what's happening. Okay, I just pull away from it. I'm in the middle of beginning the assembly. I'm going to X out of that for now because I want to come over here and change my units, which is under document properties, units, and I'm going to go with millimeter gram seconds. Will probably be fine. Yeah, we'll go with that, and OK. And now what I'm going to do is drag in my first part. So I'll go back to my Windows Explorer, take part 1, drag it in. Since I've just dragged it into an assembly, the system knows that I'm wanting to put that part into the assembly. It has made it fixed, and I am perfectly fine with having that part fixed. Now, turns out I actually need 2 of these parts, and so I'm going to drag a second copy of this one in from that same window. I will drag that one in, and now what I want to do is bring these parts together. Let's go ahead and center them up in the window. I'm going to rotate so I can see their bottoms, and I'm going to click on that bottom and that bottom and select a mate, and the mate that I want is coincident with no offset. That's good. I'll accept that one. I'll rotate around to these faces here and there, and I want them to be coincident as well. And then I'm going to select, and I'll check on that, and then I'm going to select this face and that face. I want them coincident but with an offset distance, so let's put that back, and let's make that about 150 millimeters. That's probably about right, and I will accept that, and I am done. And let's make everything fit the screen nicely. And notice my part number 1 here has no plus or minus or anything next to it. That part is totally fixed. And those 2 parts are going to be my ground feature for this moving machine. Both of those are connected solidly to ground and cannot move. The next part that I'm going to bring in is part number 2, a link. And now I'm going to connect this link in as part of a moving machine. And so I'm going to go ahead and turn on mates. And I don't want standard mates. I want mechanical mates. And what we see in mechanical mates is connection between parts using sort of machine design notations, cams, hinges, gears, rack and pinions, screw connection, U-joint connections, those kinds of things. And one that's used most common in machines is the idea of a hinge. So I'm going to click on hinge, and let's look at what it says here. It says concentric sections. Hinges usually involve round stuff, so what needs to be concentric? I'm going to make this surface of that part concentric with this surface of that part. And then it says coincident section. With a hinge, there's a concentric section that lines up two circles. The coincident section tells how to line it up left, right. I'm going to make this face coincident with that face, and I'll make them touch. And this mechanism hinge is fully defined. Now, if I wanted to, I could specify that this hinge can only move to certain angles. Okay, I'd have to define the angle somehow using maybe this face and that face, and then I could tell sort of plus or minus the maximum angle, minimum angle, those kinds of things. We're not going to do that for this one. We're going to let it rotate 360 degrees. This joint is done, and let's see. It says that this one is under constrained, but that's intentional because we want this joint to be able to move. And you see how I can drag this one around just fine. I cannot drag this one around, but we do have a fully defined mechanism joint here. Now I'm going with that one fully defined. I'm going to go in and grab part number 3. Drag it in, move my window back out of the way. Now what I've got to do on all of these is make sure that things are going to stack up properly. So let me work a little bit more getting this aligned well. What I'm trying to do is get the two base parts aligned. What I want to do is take this part and place it on this side of this link, on the outside, because I'm going to have another part that's going to come back in. So this new part on the outside of this one, on the right side of this one, where these ground points are on the left side of this one. And so now I'm going to do another pin joint. And I'm going to go with mate. Let's rotate a little bit. And I'm going to mate this to, let's see, I need to say mechanical mate, hinge. And now with a hinge connection, I want that face to be concentric with that face, and I want this face to be coincident with that face. And you can see how it brings them together. I'll accept that joint completely, rotate around a little bit, and I can grab this part, and I've got a connection that moves both. Or I can just grab this part, and this one just stays without changing angle. Alright, I've almost got a closed loop mechanism. These two cannot move. Right now what I've got is a little 2 degree of freedom robot. It can move, if I put motors and control this thing, it can move in planar space to just about anywhere that's within its reach. But we're not actually doing a robot, we're doing what's called a Fourbar mechanism, or a closed loop linkage, and I'm going to take part 4 and bring that in. Oops. Let's see, where did I go? There we go. I'm going to take part 4 and bring that in as well. Move this back out of the way, and I'm going to connect this pin joint to there and that joint to there, and this one needs to go to the left of this one, so that it will be, actually this one will end up being in the same plane as that first one that I assembled. That way I can connect one side of this part to here, the left side of this part I can connect down to the bottom. You'll see what happens there in just a second. And so I'm going to do a mate and connect this surface concentric with that surface, and this surface, oops, I need to tell it that I'm doing a mechanical mate and that it's a hinge, and then my surfaces look better, and then I'm going to do the coincident, that surface connected to that surface, and it has brought them together, and that is a good pin joint. Now I'm going to do another one, which will be another hinge, this surface concentric with this one, and let's see, this surface coincident with that one. Okay, I had to pause this video because my cell phone rang and I answered it, but I'm back. Let's zoom the mechanism out and see what this thing does. This thing's called a four-bar mechanism because we count the ground as one link, and we get coordinated motion among all of these various links. I'm going to go ahead and rotate this one around to the direction where I want to visualize this thing. Something, my mouse goes a little crazy, bear with me. Something about like that. Okay, and so you do see, though, for the first time, that when we have an assembly of parts, we can, in fact, make that assembly move. Now what we're going to do is take advantage of that and put a motor on it and do some analysis of this thing and then make a movie of it. Notice down at the bottom here there's something called Motion Study 1. So we're going to click on the Motion Study tab, and there are three kinds of motion tools in SolidWorks. There is animation, there is basic motion, and then there's motion analysis, which is a bit more sophisticated. I'm going to go ahead and choose motion analysis, and because we're going to be doing some plots from this mechanism where motion analysis will help us understand it. First thing I'm going to do is apply a motor. So this symbol right here says add a motor. When I click on that, I have a dialog over here that says what kind of motor do I want. Could have a linear motor or a rotary motor. I want a rotary motor. It's a motor that rotates. Scrolling down a bit, this box says, what am I going to place the motor on? This says this will control the motor direction, and this describes what the motor moves relative to. And so I'm going to come over here and I'm going to place the motor on this short link, and I'm going to go ahead and click this inside circle on this first part, not the interior part. We can see the direction going that way. If I want, I can reverse it, but I won't. I'll leave the motor so that this link will move outward away from the rest of the mechanism, and then I want it to rotate relative to this part. Okay, then I have some other things that I can set. This is a constant speed motor. It could be an oscillating motor. As a matter of fact, for now I'm going to make it an oscillating motor, and it's going to oscillate plus or minus 90 degrees at 1 cycle per second. And let's see, this one is phase shift. Do I want to start at 0 relative to here? Do I want to jump over some? And what they give is a graph of the kind of motion I'm going to get out of this machine. I'm going to accept the oscillating motor for now. Let's center up a little bit better. And now what I'm going to do is compute or calculate the animation. And we can see that link rocking back and forth. And it's rocking back and forth several times as the calculation goes on. Calculation is done, and then anytime I wish I can play the movie. Movie is moving a little bit faster because it's not calculating, and so I can see that happening. That would be an oscillating motor. If I wish, I can go find my motor, right click on it, edit it, and I'm going to turn it into a constant speed motor. I'll leave that at 100 RPM. I'll leave everything else the same and accept that and recompute. And now we got a little bit better idea on how this thing moves with a continuous rotation motor. It'll finish up in just a moment. Okay, and then anytime I wish, I can play the movie. This says play from the beginning, and that thing is cranking like crazy. That's almost too fast. If I want to watch the motor slower or move these slower, I can run at half speed. I can run at quarter speed. And let's play from the beginning again. And now I'm running at 1/4 speed. I can stop, pause, whatever. If I wish, I can grab this timeline bar and maybe move to some interesting position somewhere within the movie. It's a little bit coarse, but it works. Let's see, does this expand the timeline? Probably. Oh, let's see, zooming in on the timeline gives me a little more fineness in the ability to control where I'm going to go in this thing. So by, let's see, zoom to fit, that's probably a nice one. No, that didn't do all that well. We can zoom in a bit more, and that's almost too much. I'm going to come out one. And that timeline fits my window fairly well. And then if I do want to drag my time marker, I have a little more control on it with a slightly bigger timeline. I'm going to zoom out one more though and call that good enough. Okay, so now I'm able to make a movie of the moving machine. The other thing that I would like to do though, well, let's see, let's do one other thing. I can make a recording of that movie. I can save this animation as an AVI or other file type. We've already done an AVI for an exploded view. We've seen that. So that's the process we'll use. And I will save this. Let's see, I can choose where to save it. And so I'm going to go Fall 2011 Mechanism Analysis, is where I'm going to save mine. And I'm going to save the assembly 3. I'm going to call this Fourbar .avi. And I will save that. And it's ready to make the video. Let's see, Microsoft Video 1. I guess there are various encoders, but I'm going to stick with the Microsoft one and say OK. And it's busy taking pictures to make the movie. Okay, the movie is done, and if we take a look at my Windows Explorer window, we can see fourbar.avi. I'll double click on that. See how big this ends up looking. Okay, it's showing up in the middle of the screen, and there's the fourbar.avi movie. Interesting, it doesn't play all that smooth, but we're going to certainly call that good enough. I'm sure there are things we could do to smooth that up a bit. I'm going to stop that. I'm going to move this. We've made our movie. The next thing that I want to do is to do some measurements on this thing. Because I'm doing motion analysis, I've got the ability to do some plots, and here is our results in plots. So I'm going to click on this to create a new plot, and it says select the category for the kind of thing you want to plot. We could plot displacements, velocities, acceleration, forces, momentum, energy, power, other quantities. I'm not sure what's there, but I'm going to go with the displacement kind of thing. Now there are lots of kinds of displacements. For this case, I'm going to plot the angular velocity of this link. And this one's already selected. That was an accidental thing, so I'm going to delete that. I'm going to delete that. And in fact, what I want to plot is the angular velocity of this, what I would call the output link. And I do need to select a result component. I could do the X, the Y, or the Z angular velocity. I could do magnitude, which would be easiest, but then that hides the sign of the velocity because everything comes out positive. So I know I want to do the angular velocity measured about an axis perpendicular to the face of this part, or measured about an axis in the direction of the center line of this hole. The center line of this hole I know points in the Z direction. If I rotate a little bit, the Z direction points in the same direction as the center line of that hole. So I want to look at Z direction angular velocity for this one. Let's see, this one says component to define XYZ directions. That's optional. I'm going to leave that alone. And so that's the graph that I want. This one says create a new plot and plot versus time. And that is what I'm going to do. I will accept that. And there is my graph. And it shows, and the scales maybe could be a little bit better, and I'm not sure. I haven't played around with this enough yet to know what options I have on scales. But that's a positive 332nd, but a very fast negative angular velocity. It moves very, very fast, comes to a stop, and then moves in the forward direction. It's finally, and is moving pretty slowly. We're going to run the animation again in a moment and see if we can see that. But what can we do with this plot? Well, one of the things we can do with it is copy it to the clipboard, or we could export it to a CSV file, which would probably export both the data and the plot. Maybe just the data. Let's go ahead and do it. I haven't done that yet. Just for fun, I'm going to do that, and I'm going to put that in my documents. And you're not going to have these directories, of course. Classes 1332. This is probably a directory you'd like to have. Fall 2011 mechanism and fourbar.csv. Save. And then I come back to my working window and I see fourbar.csv, an Excel file. We will open it. Okay, and what I have here is merely the data for this angular velocity, but you've played with Excel. You know that we can take this data very quickly. I'm selecting it all, and with the data selected we can do a plot, but I'm going to do a line graph that would look like that one. It's putting it, I think, pretty much in the middle of the screen, and we're getting pretty much the same plot that we had seen before. So we could go to Excel and turn it into a plot. No, I'm not out of Excel entirely. I'm going to move this out of the way. There's our plot. The other thing we can do with the plot is copy it to the clipboard. Now I'm going to open up a new Word file, and we'll paste it into that new Word file. At least I think I'm opening a new Word file. It's kind of slow. Oh, clicked on Pro Engineer. Heaven forbid we should talk about Pro Engineer in this class. I'm going to pause. Okay, I'm back and got Word open, and I'm just going to click in Word. I'd already copied to the clipboard the plot, and then I can paste that plot into Word if I wanted to. I'm sure I could paste it into Excel as well. And so one of the things I would like you to do is paste this plot into a Word file. This is part of your homework assignment. Make the mechanism, do this plot, paste it into a Word file, and then print the Word file as a PDF file, or you can do a save as PDF. Save the PDF file, then upload this particular plot of angular velocity versus time to the online classroom site. That's part of your homework. I'm going to go ahead and exit Word. I'm done with that. Do you want to save changes? No, I'm not going to save changes. I'm going to close this plot. And if we wanted to, we could plot lots of other things. So what I want you to do is build this mechanism and make a movie, upload the movie to the online classroom site, Dropbox, and do the graph of angular velocity of this link versus time, and upload that to, put it into a Word file, and upload that to the online classroom site as well. And that would end this week's discussion and would give you your homework assignment. So in summary, download the parts called mechanismparts.zip from the online classroom site. Create this mechanism using hinge joints, which are part of the mechanical joints, as I showed you. Make it move, make a movie of it, and plot an important piece of the motion analysis. Oh, the one thing I wanted to look at is just sort of looking at this move again and see what the graph said. And what the graph said is there are places where this thing's going to be moving slow, there are places where it's going to be moving fast. Let's see if we can spot that, and I'm going to do that by slowing the movie down even more. And let's play it from the beginning. I'd say it's moving slow, and now it's moving very fast. It's moving pretty slow, real slow, very fast. And so that showed up in the plot that we saw. I'm going to go ahead and pause the movie, and that ends today's discussion.